Hello, Mr. Miller and fellow peers that are watching this as of right now. We were blessed to be given the opportunity to work on Lab 3 regarding string length and how it affects the rotational speed. In the following video, you will be informed about this by Hen Rizzle,
Brandon Bling Bling,
and T-Flavor J. Our project question is, will the length of the string affect the rotational speed of the flying pig? The rotational speed, which is the independent variable, is changed depending on the length of the string, which is the dependent variable. We know that the study subject, the pig, is affected by gravitational force and also applied force from the flapping wings of the pig. The flying pig also experiences string tension. We hope that this experiment will show whether the rotational speed of the pig is affected by variables such as the string length, depicting the overall relationship of the string length and RPM of the flying pig. Our claim is that the rotational speed of the flying pig will decrease when the string gets longer and increase when the string is shortened, because the flying pig goes at a constant velocity no matter what the string length is, and since the longer string depicts the larger radius for the pig to cover.
What's up, it's Hen Rizzles, and today I'm going to be informing you guys with our method, data, and video analysis. The dependent variable is the rotational speed, which can be measured in two ways, theoretical and experimental. The independent variable is the string length measured with a meter stick. First, get the videos of the flying pigs moving in a circular path from the teacher. One of the videos should have a pig going in a circular motion with a string length of 42 centimeters, and the other should have a string length of 85 centimeters. The study subject, which is the pig, should have a constant mass of 187 grams. The string length should be the only variable that is changing while the mass of the pig is kept constant. Find the experimental values, which is data collected from the lab, for each string length by plugging the video into Tracker, and record the number of rotations the pig makes per minute. To solve for the theoretical values, which is basically using equations to predict the results, we would get the radius of the flying pig from Tracker using trigonometry to obtain the angle data for us to use in the formula. Time equals square root 4 pi squared radius divided by gravity times tan of theta. Then graph the two values, experimental and theoretical. Look at the information the graphs gives you and determine whether the relationship between the rotational speed and string length is inverse.
As you can see from the graph, the pig with the shorter string length, 42 centimeters, has a faster rotational speed of 47 rotations per minute compared to the pig with the longer string length, 85 centimeters, which has a 36 RPM. This is due to the difference in distance that each object must travel. The longer the string, the more distance the object must cover to complete a full rotation. The force on both objects remained constant, which made the string length the only variable that can affect the rotational speed. Some problems we faced were while using the program Tracker. It was difficult to find a point of mass that would continue to be tracked. Shout out to Mr. Miller, who thought of some ingenious idea to attach a green light and film in the dark, creating a clear point of mass that was easy to track. For future investigations, we can replicate the experiment using a different type of string that doesn't release any tension that may affect the data. This will allow for less external factors to affect the study subject, resulting in a more accurate experiment.